7-1, we're looking at the Pythagorean identities. That word should sound familiar, Pythagorean. And then we're looking at sum and difference identities. This chapter, all of chapter 7, is all about formulas. Okay? I'm going to give you the formula sheet. In fact, I'll go ahead and give it to you right now. Nope. Wait, y'all are right here.
What is this?
3, 2, 1.
You can have that back. You can have that back. What is this?
That would be the formulas that I am going to teach.
You have an extra one?
You have an extra one?
I didn't think to put it on a nice little colored cardstock paper.
So this is just the first half of it?
Yeah. This is not the end.
Wait, this is 7.1
This is
through
1,
3.
2, 3. 1, 2, and 3.
What's our final exam paper gonna wait? There's an extra one?
Why?
I was
I
gonna
want to
rip
rip
this
this
up.
one.
No, you don't get to rip it. No. All right.
What if I actually just rule?
Hold that formula sheet to the side. Please don't. Did I not count right? Listen. Please don't look at it and panic, okay? It's kind of like if I was to look at like my workout in advance, I'd probably talk myself out of doing it because I'd be like, oh, good grief, there's star squats, there's Bulgarian split squats, and all that stuff that I can't stand. Don't look at it and panic, okay? Look at it and be proud of where we're going because you're going to know how to do everything on there. You already know some of it. The unit circle's on there. You've already learned it. Okay, so don't, that's just noise. All right, y'all with me?
I've got 35 minutes.
Okay, first slide. We are looking at your basic identities. These should look familiar. Y'all with me? These should look familiar. I'm telling you, you're going to be lost. These should look familiar right here. The ones that you recall, sine, cosine, tangent, you will notice you can rewrite it as a reciprocal function of the cosecant, secant, cotan. We've also talked about tan is really sine over cosine, which means cotan is cosine over sine. You already know all of those. They are on that formula sheet, I believe, right? Are they on there?
Yeah.
At the top. All of those are at the top.
Basic.
Now these over here, you may not remember them because we've really not used it a lot yet, but they are going to come into play. And it means that if you have the sine of a negative angle, you can rewrite it as the negative sine of that positive angle. It means that if you have the cosine of a negative angle, you can rewrite it as just cosine of the positive. This is because of the symmetry of those graphs. We talked about this one day. We talked about how sine is symmetrical to the origin. You take sine and you turn it upside down and it's the same graph. So that's why it has this relationship. We talked about cosine is symmetrical across the x-axis. We talked about tangent. We didn't talk about tangent symmetry because it's ugly. But tangent has a symmetry that if you take tan of the negative angle, you could rewrite it as the negative tan of the positive angle. So these are different ways to write it. Instead of me saying to you, here are 3 equations that we're going to start using, I want to derive them because I want you to see where they come from. I don't want to just throw at you sine squared plus cosine squared equals 1. Let's run with it. Because then you're going to be like, I don't understand where that can, like, you're going to be like, oh, that's cool. But you're not going to understand where it comes from. It's coming from the Pythagorean theorem. Okay? If you think back to the unit circle, remember we said that the triangle that's formed is an x-coordinate, a y-coordinate, and that the unit circle's radius is what? 1 all the way around. So this is the Pythagorean theorem from the unit circle. What I want to do is take this. You will notice in all of this that instead of x comma y, they're using what for x? Careful. Cosine. And we're going to go ahead and start writing theta. So they're using cosine theta, and instead of y, they're using sine theta. We are going to replace, for x and y, cosine theta, sine theta, right here in the Pythagorean theorem. So this would give me cosine theta squared plus sine. Let me move this bar over so I don't run out of room. Cosine theta, bless you, squared plus sine theta squared equals 1. So all I've done there is substitution. All I did was substitute. Cosine theta for x, sine theta for y. Now what you're going to have to do is to remember your rules of exponents. If I'm taking something and squaring it, that means it's multiplying it by itself, right? Twice. Okay, so cosine theta squared can be rewritten like this. Now this is new. It can be rewritten like this, cosine squared theta. That means that it was cosine theta times cosine theta. You don't square theta. Theta doesn't change, right? You square the cosine. So that's why that little squared is there. It means cosine theta times cosine theta. So the way you write it condensed is cosine squared theta. All right, this would be sine squared theta equals 1. That is your first trig identity. That's your first one, Pythagorean trig identity. You actually already know trig identities. I'm sorry, let me back up. You've already learned a whole slew of trig identities. This is your first Pythagorean trig identity because it came from using the Pythagorean theorem. Unfortunately, this is not the common way to write it. I don't know why, because it's alphabetical order, but it just doesn't roll off the tongue as well. Sine squared plus cosine squared equals 1. You see what I did? Cup game. Is the proper way to write it. So I'm going to write or, and I'm just going to cup game that like this. And then if it were me, I would take a highlighter and I would highlight that. I am actually going to box it in. And then I'm going to highlight it. That is the first trig identity from the Pythagorean theorem. And you're going to want to memorize it. It makes life easier if you have it memorized. You have a highlight. I know,
but Brody's having fun throwing
it.
I'll let
Well, could you, let me show you how to throw it. Who's catching next? Nobody. You can throw to me. You're flinging it. Like, just do this.
No. See, that makes it complicated. If you fling it, it makes it easier to catch.
No, it's like a
I'm
propeller
gonna fling it, and he's gonna catch it, okay?
Oh Lord, Aiden, watch your head. See? Oh.
See?
No, that was a terrible throw. I just have wide receiver hands. That was a baseball pitch.
Does this one not work?
No, it's just like
She said it was.
There goes $5.
I don't like it.
well, what if someone else likes the color?
Then they have bad taste.
That was sad.
And the lid
That
cap.
was
So we'll
You could have caught it with your finger before your hand.
Use that.
We're building all of these identities. That's just a fancy word for formulas. We're building all these formulas so that we can manipulate equations by using substitution, which means in an equation, if I ever see sine squared plus cosine squared, I now know I can erase that crap and I can replace it with a 1 because they are equivalent. Okay? Now, we're going to repeat this exact same process, but we're going to stem from this one. We're no longer going to do x, y, and 1. We're going to stem from sine squared, cosine squared equals 1. So I want you to bring that over here. Bring it over here. Now remember the rules of equations. You can do anything you want to an equation as long as you do it to both sides, right? So in this equation, I'm going to divide everything by sine squared. Don't ask why. I'm just going to divide everything by sine squared. So I'm going to show my work by doing that. So I'm going to divide this by sine squared, divide this by sine squared, and divide this by sine squared. Now I'm going to clean it up. What is sine squared divided by sine squared? 1. Anything divided by itself is 1. What is cosine over sine? Careful.
Cotan, sorry.
It would be cotan. Now, this is cosine squared over sine squared, so it would be cotan squared. They do have to match. The exponents have to match for you to be able to say, hey, that fraction is actually just cotan squared. And then what is 1 over sine squared in reciprocal form? Cosecant squared. You have just built your second Pythagorean trig identity. I am not asking you to memorize this one. You will have a formula sheet. The first one we built is the one you need to memorize and maybe just be familiar with it. This is another one of those things where I was saying the only way this chapter gets easier is if you practice and if you're reading these trig identities, not your cell phone. If you're reading these trig identities, I promise they're going to start to like pop up in your mind. As you're doing the homework, you're going to be like, wait a minute, I feel like I've seen that before. You'll go to your formula sheet and you'll be like, oh yeah, there it is. That's how this gets easier, okay? In the past, I've seen people struggle in this chapter, and it's because they're not familiar like with when to substitute, because they never looked at the trig stuff. They never tried it. All right, we're going to repeat. Notice I didn't highlight that one because that one's not worth memorizing. We're going to repeat coming from sine squared plus cosine squared. Get it right, I should. Cosine squared equals 1. And what do you think I'm dividing by this time? I'm going to divide by cosine squared this time. If you have like a colored pen, or if you have erasable pen or something like that, it might be helpful in this chapter to be able to write the difference between what we started with and then the work we're doing in between. All right, we're going to clean this up. Sine squared over cosine squared is what? Tan squared, right? Cosine squared divided by cosine squared is 1. And then the reciprocal function of 1 over cosine squared is secant squared. Notice theta never changes. Theta stays the same. You're manipulating the actual trig part. Oh, I did say your resin. Anyways. All right, turn to the next slide. Yeah. Yeah. Turn to the next slide, and then you're going to notice what I've done is copied the 3 Pythagorean identities that we just derived. I've copied them to right here. You'll see these arrows coming out of them. The arrow is saying, hey, there's more involved here by just doing a cup game. Look at the top one. Sine squared plus cosine squared equals 1. Well, if I subtract cosine squared to the right, I'd end up with sine squared equals 1 minus cosine squared. See that? Well, if I subtracted sine squared to the right, I'd end up with cosine squared equals 1 minus sine squared. So that one equation actually has more formats by just doing like a cup game with your values, okay? What do you need to actually put on your paper? I want you to box these three in, right here, and I want you to make a note, memorize them. Now when I say memorize, I really mean memorize the top one. The other two, familiarize, right? There's a difference, meaning if you've got the top one memorized and you remember us deriving the other two, you could get to the other two. The more accustomed you are to those expressions, the easier the practice is. Think of it as like in a weight room. If you don't know where the weights are, then your workout takes longer, right? And it's stressful because you're just like, where's the 10s? Where's the 15s? Where's the 20s? Familiarize yourself with the equations, and then the process is less stressful. These over here, you don't have to memorize. Just remember that while this equation is the one I'm memorizing, I could shift this stuff around, and then I have a totally different equation. Okay. You do need to recall also that tan is, so tan of x, if x is the angle, can be rewritten as how? Sine x over cosine x, right? I brought that over here to this page because we're going to need it here in a second. Well, x, so when x is written in the position theta normally is, it means angle measure. It does not mean x coordinate, which is a little frustrating because, the whole time we've dealt with it is an x coordinate. Now you're going to see when it's in here like this, it's an angle measure. If it bothers you, replace x with theta or alpha or whatever. Just know that if it is coming after a trig function, it's an angle. Okay? All right. These first two practice problems are looking to see, can you do basic algebra, but with trig functions, and then clean it up? Okay? Treat these like blocks. We've got cosine x, parentheses, tan x minus secant x. The directions are telling you what to do. They want us to multiply, and then they want you to simplify. Well, this is two terms in here. This term's in the front. If this was just plain old numbers, let's say like that, you would do what with the two? You distribute. So we're going to take cosine x, think of it as a block, and we're going to distribute to tan x and secant x. When I distribute a trig function to another trig function like this, you're just shoving them together. Like think of magnets that they just draw together by multiplication. So cosine x, tan x would be my first term minus cosine x, secant x. Remember, terms are separated by plus and minus signs. So I have two terms here, right? The directions say simplify. Here we go. This is like baby steps into using your trig identities. Cosine is just cosine, but what's tan? Tan is sine over cosine. Notice my x that is the angle measure just gets copied. All I've done here is replace tan with sine x over cosine x minus cosine x. What's secant? 1 over cosine x. It helps if you write them kind of like in line with each other. Notice my cosine x is in line with my 1 to remind me that that cosine x is understood to be over a 1. Because now you should notice that there's stuff we can do here. We can simplify this cosine x is being divided, right? It's divided by cosine x. But this one's being multiplied, so they cancel out, right? And then what about over here? Same thing. This is a cosine x being multiplied in, but right after that, it's getting divided out, so they cancel out. And now we're going to write what's left. You have to read it carefully. We have a sine x minus 1 left. Which means if you were to go to your graphing calculator, which I wouldn't encourage this because it would be a hot mess, but if you were to go to your graphing calculator and you were to graph this, then graph this, they're the same graph. What you've done is taken an expression, you've multiplied, simplified, cleaned it up, you have the exact same expression, but it looks totally different. All right, the next question is saying factor and simplify. So, yes, we can multiply trig functions together. We can also recognize when there is a GCF of a trig function, and we can factor it out to the front. So if you look right here, we've got sine squared. You'll notice I don't even read the x sometimes because it's just more to say that has not a role at all in the process. Every single one of these is x. So I'm just going to focus on the trig part. I've got sine squared, cosine squared. So that's one term. They're multiplied together. Plus, then I've got cosine to the 4th power. You see that? If this is hard for you to read at first until you get better at this, then think, since this was just sine and cosine, think of it like this: y squared x squared plus x to the 4th. What did I do? I put the x and y variables in place of sine and cosine. This might help you to see the GCF and what you can pull out until you get better with the trig functions, okay? So clearly I can see they both have a cosine, right? Not only do they have a cosine, they have a cosine what in common? They have a cosine squared. GCF is always the smallest exponent. So I can pull, just like over here, I can pull an x squared out. I can pull a cosine squared out. So we're going to make a note. I'll write it here. Cosine squared x. And then we'll make a note that that is my GCF. Now I need to write what's left if I divide that to the front. What would be left from the first term? Sine squared. Copy the plus. Cosine squared. And then I would always encourage you to multiply it back in your head as a checkpoint and make sure you get what it came from. If you multiply this back and you don't get what you came from, you've done something wrong. Well, what do you notice? And this is the first time, so the fact that no one said it yet is okay. What? What's 1? What is sine squared plus cosine squared? 1. So all of that is really just 1. So I'm going to bring down cosine squared x. I'm going to put 1 in parentheses. And cosine squared x times 1 would be cosine squared x. Yeah. 2 more slides. We're gonna, yeah. Go to example 3. Now, this is where you may have to pull that formula sheet out and have it next to you, okay? Pull that formula sheet out next to you.
Change flip. Keep flip change. Wait, no.
Keep like,
Sorry.
I'm sorry. Keep change flip. So you would have.
Okay, so here's another part where this chapter is challenging, which is now you can see exactly why we're not taking the test on my math lab. Pretty much every single one of these, for the most part, the majority, you could solve in a different way, and we could still come to the same answer, and they're right. I did not see keep, change, flip. I saw something different. So I'll be happy to work both. I'm going to work the one that I saw, and then I'll work keep, change, flip. So when you first look at this, you've got cotan of a negative theta. You've got cosecant of a negative theta. I don't really want to work with the negative theta. I don't want to worry about it yet. I want to get the cotan and the cosecant simplified. Like, I know cotan is a fraction. I know cosecant is a fraction. So I definitely have a fraction in a fraction, which keep, change, flip works. I said that this could be rewritten, and then I wrote cotan. What's cotan? You need to look at your formula. That's cosine. Now you got to keep the angle the same over sine. Then we've got in the bottom cosecant. Well, if cosecant's in the bottom of a fraction, that's the equivalent of sine, right? 1 over cosecant is, look at your formula sheet. Go to your formula sheet. Let me actually pull it up so we can practice looking at it together. One over cosecant, right here, is what? Is just plain old sine. So I saw in my head, I was like, that's 1 over cosecant, so that's really just sine. That's how I saw it. Now, you may not see it that way, which is fine, because keep, change, flip also works. I'll show that to you in a second. What happens with the signs? Yeah, this one's division and this one's multiplication. The angles have to match, and they do match. So I'm left with cosecant of negative theta. And then go to your formula sheet. Your formula sheet says, let me zoom in. Should be up here at the top, right? There it is. Cosecant of a negative angle can be rewritten as just, not cosecant, cosine, as a positive cosine of that angle, of positive angle, right? You see how to read this? Cosine of a negative angle can be rewritten as cosine of the positive angle. So this cosine of negative theta can be rewritten as cosine of theta.
Is that only with cosine?
Yes. Yeah, if you look at your formula sheet, sine is different. Now, what if you didn't see it that way? What if you saw it as cosine negative theta over sine negative theta, big fraction bar, cosecant is 1 over sine theta, negative theta. Just remember to write your big fraction bar as the really big one, so you'll know where to keep, what to change, what to flip, right? So keep, change, flip. All right, keep. Change. Flip. What do you notice compared back to mine? It's the same thing. But the thought process was totally different, right? So then this would finish. I'm going to say like ... This would finish. It's the exact same. Which is exactly why. Yeah.
What is it? Because he gives the opposite.
There's a lot of keep, change, flip going on in this chapter. But notice, while the rest of the problem would be the same, do you notice that my first step is this, but this first step is this, which is not the same. This is why I don't want the exam on the chapter on my math lab, because my math lab is going to expect you to do it their way, and you can see there's multiple ways, right? The only stress would be in the homework, which is why we have so many days for these sections, because I anticipate you to say, I need help with the homework. I need help with the homework.
Oh, I need help with the homework.
Which is exactly what. Now, that's not me doing the homework for you, but that's you having the time in class to be able to ask a question that I'm sure everybody wants an answer to. That's why this chapter is stretched out like it is. There's only one type of question where they make you do drop-down menus and write the next step. And that's when I get annoyed.
You should just take that off.
The overall questions are where it will, it's the bug guy. The overall questions are where it will say, hey, clean this up, and you would go to my math lab and you would type cosine theta as your final answer. So that's one of the reasons why we're sticking with the homework, because it's not bad on that part. It's just the ones where it's a drop-down menu. What's the next step? That's when you have to fall in line with their thought process. And there's not a lot of those, by the way. All right, look at the next one. When you first look at it, it's, woo! We got, woo, it's not pretty. We got 2 sine squared t. That is an angle. They are naming the angle t. If you don't like that, change it to theta. We got 2 sine squared t plus sine t minus 3 over 1 minus cosine squared t minus sine t. All of your rules from Algebra 2 are still here, okay? This is why in college algebra we spent so much time on factoring. You're going to be factoring trig functions, okay? If I had to guess, this is probably a hot mess, right?
Yeah.
Yeah. But you'll notice that we've got sine and then we've got what? Cosine. So you could rewrite this in just like y and then an x if you needed to. So I'm going to I'm going to make note like top, meaning I'm just talking about the top. So that's 2 sine squared t plus sine t minus 3. That's really just 2y squared plus y minus 3, right? You see what I did there? That looks so much nicer. Now on the bottom you do have an x and a y, so it's not as simple there. So we'll hold off on the bottom for a second. Alright, so this is where you got to get uncomfortable. This is what people start giving me pushback. You've got to get comfortable being uncomfortable with the problem and then working through it. Okay, don't give up on it. Every single one of these problems is annoying, but you're gonna get to the other side of it. You've got to keep in the back of your mind it's a puzzle. You need to rearrange the puzzle so that you can see it better. Factor when you can factor. We have a trinomial. I've written it in simpler terms this will factor. Here's your factor refresher. A times C, what? C, negative 6. The factors of negative 6 that add up to positive 1.
3 and negative. No. Yeah, 3 negative.
So 3
No, it would be 3
and 2. Which one's negative?
2.
2 would be negative. So do they multiply to give me that? Yes. Do they add to give me that? Yes. Now, this is where you may want that shortcut I taught you in college algebra. Let me refresh you on it. You come up here and you draw your parentheses. A, and then X, but in this case it's Y. A variable goes in the front. 2Y is your variable. 2Y. The numbers you came up with down here go after it. So we got plus 3, minus 2. One of the set of parentheses will be done. This one's done. One of them will clean up. When we say clean up, we mean like a GCF will just divide out of thin air. It's going to disappear, right? 2y minus 2 will clean up to just y minus 1, and now it's done. Right? Don't write the 2 anywhere. This is a shortcut. I can't explain where the 2 goes. It's the shortcut works every time. And you can factor much faster. So we took an ugly trig function. We rewrote it with just y so we could actually see the polynomial. We factored it using the fraction, or not the fraction, the parentheses method, the AX method. And then now what I'm going to do is take this, and I'm going to rewrite that in there. Let me erase that. All right. So that fraction on top. Now, everywhere there's a y, I'm going to write a what? A sign of what letter? T. So I'm going to rewrite 2 sine t plus 3 parentheses sine t minus 1. I do, yeah, I curl my t so they don't look like plus signs.
So we just do the same thing in one.
Well, now the bottom has 2 different variables in it, so there's something different going on in the bottom. Here's where we are puzzle problem solvers, okay? You're going to need your formula sheet. The fact that there's 2 different variables here is your indication this is not a traditional factor problem. We've got to get creative. We've got 1 minus cosine squared minus sine. So we've got 2 issues. We have a cosine and a sine. We have a squared and a not squared, right? This is your indication that there's something in here you can substitute, because we don't have, like, we're not vibing here, you know? We got 2 different trig functions. We got 2 different exponents. There's something wrong. Go to your formula sheet. Start looking around. There's something in that formula sheet, and it may actually not be on the formula sheet, but it's a cup game from the formula sheet.
I don't like them.
Yeah, get over it.
I like that picture.
You could look at the top of your notes. You could look at the top, not the notes here, top of your notes.
I was looking at the other thing.
Well, you need to look at both. Like, start getting used to looking at both. What did you find?
I give up.
Don't give up. It's called productive struggle. It is now.
Not in my head.
I know, but like, your answer is on the slide I'm showing you right now.
The first one.
You're not your answer, but the thing you're going to need.
The second one.
Uh-huh. Tell me where to look. On the right. I mean, yeah. Okay.
The second.
These two? Yes. Do you notice, whoops, where was I? Do you notice that these are all sine? Okay, and then do you notice the rest of this is sine? We got a cosine squared randomly in there, and then we got a sine. So what would be, this is where you have to be strategic about it. So we've got 1 minus cosine squared can be replaced as sine squared, or we've got 1 minus sine squared, we can shuffle those together, and that can be replaced as cosine squared.
Oh, so we just replace it.
We're substitution. Remember what I said? There's a lot of substitution here. Yeah. The rest of the formula had the word sine in it. So let's not throw another cut. Like let's try to get everything in terms of sine. So this is the one I'm going to use. 1 minus cosine squared can be replaced and be written as just sine squared. So I'm going to go over here. No, I'm not. I'm going to go right here. And I'm going to make a note over here. I'm going to put note sine squared. It was really a theta, or whatever, equals 1 minus cosine squared of theta. Well, the angles don't have to match in your formula. The formula just represents any generic angle. The formula represents any generic angle, so it's theta. Well, this is t, same thing. So look at the bottom. We got 1 minus cosine squared minus sine. So this 1 minus cosine squared right here, I'm going to replace with sine squared. So if you need to make a note somewhere, you can come over here and do it. This is another aspect of this whole chapter, is you're kind of all over the place with your thoughts. You're kind of all over the place because you're thinking like, okay, that can be plugged in, this can be plugged in. So you'll notice what I do is I make side notes, and then I come back to the formula. So the bottom is 1 minus cosine squared minus sine t. I'm going to group in parentheses. You can put parentheses wherever you want, as long as you're not all of a sudden making it a multiplication problem, right? I'm going to cluster 1 minus cosine squared together so I can visually see, hey, that is actually sine squared. That's an equal sign. That's me saying, hey, that crap is actually sine squared. So now I'm going to go over here to my problem, and I'm going to replace 1 minus cosine squared with sine squared. And then don't forget the end of it, right? So this, too much, this got replaced here. You'll notice I use highlighters to try to help you keep track of where I'm replacing. Now you might think, well, that's great and all, but I still don't know what I'm looking at.
Yep.
It's still a puzzle. We now have only one trig function in the bottom. It's just sine. Now there's 2 terms there, though. Your basic Algebra 2 rules apply. I've got sine squared minus sine. Careful. So you might want to shove them together, right? You can't do that because this one's squared, this one's not. Can't shove them together. However, we do have 2 terms and there's a GCF of sine in it. Do you notice there's a sign there? Difference of squares does come up. If you remember difference of squares, they both have to be perfect. So that would also have to be a sine squared as well, which in that case it would just be 0 because they would sine squared minus sine squared would be 0. So this is the same thing as like y squared minus y. Do you see a GCF of y? So you pull a y out, right? And you'd be left with y minus 1. You see that? Always relate back to polynomials. I can pull a sine t out. All right, so I'm going to rewrite the the top, look what I do.
Excuse the interruption, teachers and students, but if you are interested in dual enrollment for next school year, please come to the meeting in the theater for Flex 1. Dual enrollment informational meeting in the theater for Flex 1. Thank you.
I'm going to pull sine t out by factoring it like a GCF out of the bottom, and I'd be left with sine t minus 1. And what do you notice? What do you notice? Now, here's where some people start to get confused. They forget when you can actually cancel. Because this is a block, an entity, surrounded by multiplication right here, and these blocks match, then they can cancel. This cancels with this expression. And I'm left with just 2 sine t plus 3 over sine t. Now, I'm not done.
What?
We leave in a minute.
I know.
Okay. I'm so listening.
Do you notice that you have a sign in the top and you have a sign in the bottom? We can separate this. Now, the top has 2 terms here. We could separate this, and then one of those fractions would end up with sine over sine, which would be 1. So watch what I do here. This can be rewritten. I'm going to put or. I can separate. I'm going to at least finish the problem. I understand we got to pack up. I got 2 sine t over sine t plus 3 over sine t. So when you separate it, the denominator gets repeated twice. Because if you think about if you were adding fractions that have like denominators, you write the denominator once. Well, if you're separating it, you write it twice. Because what happens right here, nice and neat. This cancels and leaves me with 2. And then what is the reciprocal function when sine's in the bottom? Cosecant. So this right here is actually just 3 cosecant t. And that would be the final answer. 2 plus cosecant t, or plus 3 cosecant t. And that's the answer. That would be the answer. What? Is that the answer you want? Yeah, that's the answer.